Gang. Today we're going to talk about theoretical probability versus experimental. Now, when we talk about theoretical probability, we're talking about the number, we can write this way, the number of favorable outcomes divided by the total number of outcomes. This is what we did in the first video. So for example, in a deck of cards, if I said, what's the probability of drawing an ace out of a deck of cards? You could say, well, there's 4 aces. That's the number of favorable outcomes out of 52 total. So 4 out of 52. Theoretically, if we were to draw 4 cards, we should get, an ace 4 out of 52 times. Experimental probability, on the other hand, is defined as the number of successes divided by the number of trials. Now, if you've done the Desmos activity that I asked you to do, which was this activity, you already have a little bit of experience with experimental. In this case, we spun a spinner 36 times, and we actually kept track of how many reds there were. So I chose red as a winner, and you can see that from the experimental outcome, I had 26 successes, 26 reds, and 36 total, 36 trials. So the experimental probability of red was 26 out of 36. I always characterize theoretical is what should happen versus experimental, which is what does happen, what actually happens. And we use, for experimental probability, you need to actually perform an experiment, and we need to organize our data into a chart. For theoretical, we use the sample spaces. Here's an example of the 2 dice sample space that you might have used in a previous chapter or previous section. And you can see that if I count up the number of ways that I can get 2s, here's a 2, so there's 1 way to get a 2. How many ways to get a 3? Here's a 3, and here's a 3, so there's 2 ways to get a 3. What about a 4? Here's a 4, there's a 4, and there's a 4. So you can see that you can get a 5 in 4 different ways. And then what about a 6? Here's a 6, and here's a 6, and here's a 6, and here's a 6, and here's a 6. So there's 5 ways that happens. And a 7, here's a 7, there's a 7, there's a 7, there's a 7, there's a 7, and there's a 7. So then there's 6 ways to get a 7. And you can start to see a pattern here. If you want to keep counting for yourself, you can keep counting for yourself, and you can see that this pattern, and then there are 36 total situations. So 36 total sample spaces. And we use that sample space to help us calculate, for example, the probability of getting a sum of 6 or 8. And we would go through and we would count. How do I get a 6? 5 ways. How do I get an 8? 5 ways. So the probability is 10 out of 36. That probability is 10 out of 36. That is a theoretical probability when you roll 2 dice. So what I'd like for you to do next is to do the worksheet titled Rock, Paper, Scissors Homework. And you're going to need to do this with another person. So grab a parent or a sibling, and you're going to play the game Rock, Paper, Scissors and keep track of the experimental probabilities. Good luck and have fun.